All right, hey everybody, Mr. Fortin here. You got yourself a little problem set to do today from section 1.8, planning a proof. We got the problems listed up here, but the purpose of this video is that I'm going to go through some examples. Now, I'm probably going to make these example videos every Tuesday and Thursday in the morning so that when you do your asynchronous problem set and homework, you have a couple of problems done, examples for you lying around if you do want to watch them. So this is the ones I'm going to do today. I'm going to do numbers 1 and 7 for classroom exercises. I'm going to do 3, 6, and 9 for written exercises. And finally, I'll do number 26. So little slices of everything here. Number 25, I'm also guessing people have trouble on 25, but I want to see if you can figure that out on your own. Yes, good times here. We got to have some good times. Anyways, we have here section 1.8, planning a proof. So classroom exercises is going to relate really closely to the reading. So it's important you either did the reading or watch the last lesson, because I kind of talked about this one here. I'm not going to spend much time talking about it here, but right here in the reading, sort of midway down the page, planning a proof, it says the things you are allowed to use as information provided by the diagrams, information you're allowed to use in a proof. And so this is actually sort of assessing you on this and allowing you to assess yourself whether or not you understand this, is that if we have this as our given diagram, remember our problems here have given diagrams and usually have some given premises. This one here, there are no given premises outside of the actual diagram itself. So based on our given diagram alone, are we allowed to make any of these following conclusions? You're going to have to do numbers 1 through 9. I'll just do number 1 through 7 with you right now. Okay, here's our given diagram. Let's check it out here. What do we see? What do we see? Well, are we allowed to make the conclusion that the measure of angle FOB equals 50 degrees? Are we allowed to do that? Let's see here. Well, yeah. Hey, check it out. It's given to us. So yes. Answer here is yes. These are just yes or no questions. So if they do list a degree measurement down here, sure, we can use it. Similar if they did list like angles being congruent to one another, you can use that in as a reason of proof or something like that as given, right? So you'd say given for this. You're getting it from the given diagram. So if you wanted to say that in a proof here, okay? Some of the other things here, right? If they're not giving you marking up anything, you can say sort of these kind of things here. One of which that gets mentioned is this. Are we allowed to say points E, O, and F are collinear? Let's check it out here. Well, let's see here. We got E here. We got F here. That appears to be on the same line, right? Remember, lines aren't perfectly drawn because lines are infinitely thin. Is this infinitely thin? No, it's probably like 0.1 of a millimeter wide or so, you know? So anyways, this is a representation of a line, but the point is E and is F on that line, you think, right? Is that sort of, should we consider these to be points on a line? Yes, this is the best we can draw it, right? The best the book draws it for us is that E and F are on this line here. So any 2 points are collinear, but the question is, are these 3 points collinear? And look here, point O, well, I don't see point O labeled, right? I don't see the actual point, right? There's no point here. Yes, there is a point. So when lines intersect, right? When lines intersect, they're not going to show the actual point. They're not going to indicate, like, because remember, points are infinitely small. They're undescribed terms. Not undefined terms. Infinitely small. They just show one and only one location, not like these millions and billions of locations down here that this whole circle shows here. This is a representation of a point. So a representation of a point when we have 2 crossing lines is just going to be where those lines cross here. So of course those 2 lines are crossing here. So the point of intersection is right here, point O, and of course O is going to be on that line where the intersection is here. So yes, we can totally assume, we can totally conclude that points E, O, and F are collinear in this, even though they're not just like saying it out loud. They're not saying, hey, points E, O, and F are collinear, go have fun. The deal is they drew it for us. They tried to make it pretty clear. They did as best as they could, and this is acceptable for our purposes for this book, okay? So make sure you read the rest of this here if you hadn't read it already. These are the things you can kind of conclude, okay? And I think most of these answers here, numbers 1 through 9, should be yes for your answers. All right, moving on, email me if you have questions on that one. You'll get answers in the Jamboard tomorrow too. We got here written exercises. What we got to do now is we got to write the name or statement of the definition, postulate, property, or theorem that justifies the statement about the diagram. Yes, this is what these early chapters are all about. Check it out here. So I didn't give you all of them. I just gave you 3 through 9. I wish I gave all of them to you. But anyways, we're going to do 3 of these ones here. So we'll do about half of the ones that you have to do here. Okay, so name the statement, the definition, postulate, property, or theorem that justifies the statement about the diagram. Let's check it out here. Again, this is our given diagram. And we are concluding here, it looks like this, about our given diagram here. I want you to notice here for a second, instead of step 3 and step 9, look, step 9 is actually an if-then statement, if then statement. So an if is another kind of fact, right? An if is kind of another thing given to you here. And then we make this conclusion. So we'll talk about this one in a second. Here, there's no if. Look, some of these have ifs here, right? A lot of them have ifs. Most of them have ifs. This one doesn't have an if. And the second, number 4 doesn't have an if. And number 6 actually doesn't have an if either. So anyways, number 3 and number 6 are going to be special because we are concluding this purely off the given diagram. We don't need any more facts other than the given diagram to conclude this. So that should kind of give you a hint here. If you've been paying close attention, right, taking good notes, paying really close attention, you noticed me say something towards the end of one of the videos recently. In that, if we have a given diagram, there are three reasons that we can use to immediately introduce some information to a proof. Okay, that's my hint. What are the 3 things? 3 things we can just identify, right? Potentially identify in this and say as a reason in a proof. What are those 3 things? Okay, one of which, let's maybe look to see what's being written right here. We got AD, segment AD. We have segment DB here, and we're talking about the lengths of those segments here. So AD plus DB equals AB. Ah, nice. This one is, I think I see it here. This one's saying part plus part equals whole. So, right, that's an obvious assumption here. If we have something, a whole that's made out of 2 parts, we add the 2 parts together, that would equal the whole. That's an equation we're allowed to set up, okay? The reason why we're allowed to set up is we never proved that this is something that we're able to do, right? We just need to assume it because it's super obvious. That should give you hints there that this is indeed going to be a postulate. And the answer here is the segment addition postulate, okay? So as a reminder, there are 3 things you can pull out simply by looking at a given diagram. So say you get stuck on a proof, you don't know what to say next because you're working forward here. You're working forward on a proof. You don't know what to say next. Look at the given diagram. You might use segment addition postulate, right? Part plus part equals whole. What's another part plus part equals whole assumption? Part plus part equals whole postulate. So we have segment addition postulate. So we can add segments, 2 parts of a segment together equals the whole of the segment. What about angles? Yeah, angle addition postulate, right? That's probably going to be one of your answers in one of the other problems. Angle addition postulate justifies pulling that information out. Part plus part equals whole, for instance. And then what's the third one, actually? Let's check this one out here. Angle 2 is congruent to angle 6 right here and right here. Why are we allowed to make that conclusion, guys? Why are we allowed? In a proof, we get totally allowed to say this. In a proof, why? What types of angles are those? What is this? This is the tricky thing here. People are going to have trouble with this here. Look, I'll highlight the line here, and I'm going to highlight this line here. And these 2 lines form the sides of the 2 angles here, okay? So these 2 angles are non-adjacent, right? This angle, this larger angle here will be adjacent to that one. This larger angle would be adjacent to that one. So these angles here fit the definition of vertical angles, okay? But is that our reason? Are vertical angles, is the definition of vertical angles 2 congruent angles? No, it's not. So we needed a theorem. So this should remind you of the theorem that we needed. What was that one again? That's right. Vertical angles are congruent. Really, really simple theorem, right? Just a few words you have to write out, and you can, right, we proved it before. We have it there. Vertical angles are congruent are your reason for that one here. Okay, number 9 is a bit of a trickier one. Actually. So I want to go through that with you guys together because we'll have to look a little more closely at this. It says, write the name, definition, or postulate, the property or theorem that justifies the statement about the diagram. Here, we're going to need 2 reasons, okay? Interestingly enough, they said statement, they should have had in parentheses an S here. It should have been statements, parentheses, so statement, parentheses S. So statement or statements here, because we're going to need 2 statements here. Okay, so let's break it down here. So we're not pulling out information from the given diagram necessarily because we have a given premise right here. If it's given to us that CD is perpendicular to AB, okay, then we want to make the conclusion that measure of angle CDB equals, CDB equals 90 degrees. That's our goal here, right? If this, then this, right? Then this. The deal is, do we have a reason that goes directly from perpendicular lines to a 90-degree angle, right? So think back here for a second. You might be thinking, well, definition of perpendicular. That would allow me to get there. But no, remember, definition of perpendicular lines are what? Lines that are, or lines that form what? Right angles. Okay, so the definition of perpendicular would tell us that the angle CDB is a right angle. Oops, a right angle. And I ran out of space there, so it's a little bit messy. Is a right angle. Okay, so that's definition of perpendicular. And then we'd have to use definition of right angle to go from our statement number 2. So perpendicular lines get you to right angles through definition of perpendicular, right? Perpendicular lines are lines that form right angles. And then the definition of right angle tells us that if you are a right angle, right, then you measure 90 degrees, right? That's one of the things that the definition of right angle tells us here. So here we have 2 answers. For this one here, we're actually going to have 2 reasons where it's going to be definition of perpendicular lines and definition of right angle. Okay, feel free to email me if you have any questions on that. But this one we have 2 reasons, and that one might be tricky when we go over that in class the next day. Okay, final example for you guys here. Thank you guys for watching this video, or just picking the ones you wanted to watch. That's fine too. Number 26, might as well do a proof with you guys here because that's sort of what this section is all about. It is, again, planning a proof. So we talked about planning it, and maybe you can get in my head a little bit here. And if you're in my head, hopefully you'll prove things a little bit better. Okay. One thing I wanted to call out, guys. Hey, did I copy the picture of the diagram and the given and proof statements here? No, I didn't actually do that because I need you to handwrite it out. Okay. So don't use your computer to get the picture and to get the given and proof statements here, because then you're giving yourself less of a chance to get the proof right. Okay, you see what I mean? Do you see what I'm meaning? Maybe you'll see in a second, because the idea is I want you to spend, you can time me, and I'll be talking during it. Time me. It's going to be less than a minute and a half. I'm going to copy this stuff down, but I'm also going to be talking a bit, right, about things I'm thinking about as I'm copying down given and proof statements and the diagram. So remember, a proof requires 4 things. We got to write the givens down. We got to write the proof statement down. We got to write the diagram. And finally, we got to write our statements and reasons that follow from that chain of reasoning in order to prove that proof statement's true from our given premises in our diagram here. So since our given premise is important to figuring out what we need to talk about here. Okay, cool. We're talking about supplementary angles. Very good. So you might look at it and think you know what it's talking about here. Like, I'm going to get this. But actually writing it down, it helps you think about it here. So what I'm going to think about, I'm probably going to have to say, use that theorem today, that if 2 angles are both supplementary to the same angle or supplementary to congruent angles, then those 2 angles are congruent to one another. That's my guess here, right? 3 and 5, if we can get them to be, 4, 6, I don't know. We'll figure it out here. Let's look at the diagrams. This might actually be a little trickier here. Okay, so I got that written down. Then let's get the diagram written down here. Let me see the diagram a little bit better. I'm going to draw it down. So this is where grid paper comes in handy. This is why I've been on you guys so much about getting grid paper, because let's keep it neat. Let's keep it here. Look, I'm able to do it horizontally like this. And then I'm able to maybe like space it out appropriately. So it kind of looks like what it is here. So maybe I'll go like 3 tick marks here, 3 tick marks over here, and those will be my triangles. Okay, so I'll do this. And again, we should say, what is a triangle? Because we haven't actually defined it. Okay, so there we go. And here we go. And now I'm getting involved here. Okay, so I have to deal with six different angles. So I'll go ahead and do that right now and label them up. I got 1, 2, 3, 4, 5, and 6. Okay, so by drawing it out, I'm noticing things here. For instance, what can I do? I can mark up angle 1 congruent to angle 2. I can mark up angle 3 congruent to angle 4. I can mark up, well, these aren't congruent, but they're supplementary, right? They're supplementary here. So that's an observation I'm having that helps me. I can make those observations while I'm actually drawing it out. And then I can think about what I can talk about here, okay? So maybe I'm thinking about game plan right now. I'm thinking about this here. Angle 4 is supplementary to angle 6. There we go. Angle 4, supplementary to angle 6. Angle 4 is also congruent to angle 3. Check it out. Angle 4 and angle 3 are congruent. And hey, what do we know about this here? 5 and 6 are also going to be supplementary, okay? So these here, right, they add to 180, and you got to think, we got to show it adds to 180, and therefore they're going to be supplementary, because if you add to 180, that's the definition of supplementary angle. So we got to remember the reason. Measure of angle 5 plus measure of angle 6 equals 180. Why are we allowed to say that? Okay, so Angle 3 and angle 4 are given to us, well, not given to us that are congruent. We haven't said it yet. So we're going to have to use vertical angle theorem there, or vertical angles are congruent here. 1 and 2, this isn't going to matter at all. I'm seeing now that 1 and 2 are not involved in the problem. It's just angles 3, angles 4, angles 5, and angle 6 are going to allow us to talk about this stuff and get us to be able to figure this stuff out. So here we go. So angle 3 congruent to angle 4, that's vertical angle theorem. And I showed that these are supplementary. And then eventually I want to say, because these are supplementary to one another, and we know 4 is supplementary to 6 as well, right? That 4 and 5 are going to be congruent. 3 and 4 are congruent. So through transitivity, 3 and 5 will be congruent. So anyways, it's kind of confusing right now, but if you're drawing it out, you have some things to talk about. And you can see if you can do that kind of puzzle that is this proof solving thing, kind of working through this puzzle to actually see if you can just get it to work out. Now we got to write, okay? We got to work forward and work backward, okay? So I'm going to do it. I'm going to circle this like up here. I'm just going to put this S for statements, R for reasons. Step 1, I'm going to say angle 4 is sup to angle 6, and that's my given premise. Again, 90% of the time, that's your first step here too. Okay, step 2, we have some stuff that is listed that I marked out, that I did in my observations in my diagram right here, that I can talk about because I'm going to need to talk about this here. So maybe I'll start with angle 3 is congruent to angle 4. Maybe you don't understand why I'm saying that yet, but that's fine. We can do it in a different order than the way you do it. So vertical angles are congruent. And that's maybe thinking backwards too. I got to say something about angle 3. I have something about angle 4 mentioned here in number 1. So remember, in step 2, oftentimes I'm thinking about what is the last step. I'm going to have to say something about angle 3. Have I said something about angle 3 yet in step 1? No, I haven't. I haven't said anything about number 5, about 5 yet. So maybe I'll go to that next. So now I'm saying something about angle 3. That's good. Now I'm going to move my attention to this. I'm going to move my attention to angle 5 here. What can I say about angle 5? What can I say here? What am I allowed to say? So I don't have anything. I'm not building forward at all here. I mean, angle 4 is supplementary to angle 6. I could use definition complementary of supplementary there, but I'm not going to. I don't need to in that particular proof. So let's say something about angle 5, and then we can play with it. See if we can get it here. So let's see here. Angle 5. Well, measure of angle 5 plus measure of angle 6 equals 180. Equals 180. Look at that. The two add to be a straight angle. They had to be a straight angle here. So what's the reason for that? The definition of straight angle? No, this is actually angle addition postulate. Remember, angle addition postulate is part plus part equals whole. So if you have a large angle broken up into two smaller angles, then you can add the measurements of those two smaller angles, and then they will equal the measure of the large angle here. And the difference is between this one and other angles you might use the angle addition postulate with is that we know it adds to 180 because it's a straight angle here, right? This is a straight angle right here. Boom, boom, boom is a straight angle. So this is that angle addition postulate for straight angles. Part plus part equals whole. And since we know it's a straight angle, the whole equals 180. Okay, equals 180. So this is the angle addition postulate. Okay, that was important because, right, we think back to this section. What we're doing in this section is we got those two new theorems about supplementary angles. So we want to flex that we know how to use those theorems here. So what we can say is measure angle 5 plus measure angle 6 equals 180. So that means that angle 5 and angle 6 are supplementary angles, right? They add to 180. That's exactly the definition of a supplementary angle. Supplementary, those are the pairs of angles that their measurements add. They sum to 180 here. So this is definition of supplementary angles, gets us to establish that angle 5 and angle 6 are supplementary angles. And why is that important here? We actually are going to be able to finish the proof in the fifth and final step will be the last step of the proof here. Angle 5 and angle 6 are supplementary angles. So we have a few statements of supplementary angles being said so far. We have this, right? Angle 5 and angle 6 are supplementary angles. We also have angle 4 is supplementary to angle 6. So interesting. Two angles, look, angle 4, actually, we're not going to be able to finish the proof quite yet, but two angles, angle 4 and angle 5 are both supplementary to the same angle. So that means what about angle 4 and angle 5? Angle 4 and angle 5 are congruent to one another. So we can jump to that as a conclusion. Angle 4 is congruent to angle 5. And the reason for that is, look, they're both supplementary to angle 6. So reason for that is if two angles are, oops, keep doing that. insert text box, are supplementary to same angle, then they are congruent to one another, which was one of the two proofs that we proved in yesterday's lesson here. Okay, so and again, I didn't word this exactly the way the textbook has it, but it's clear. I've fulfilled my given premises so that if two angles, 5 and 4, are both supplementary to the same angle, 6 and 6, then we must be able to conclude that they would have to have the same measurement if they're supplementary to the same angle. Angle 4 is congruent to angle 5. Okie dokie. Have we gotten to this here yet, though, guys? Have we gotten to what it is we need to prove? Angle 3 is congruent to angle 5. No, we have 5 connected to 4 right now. And we also have 4 connected to 3. And look, 3, look at this. This is underneath. We have the yellow in front of it here. That's good. 3 connects to 4 and 4 connects to 5. So here we have 2 things, angles 3 and angles 5, that are each equal to the same thing, right? They're both equal to angle 4. So therefore they are equal to each other. And that, my friends, is that powerful. It kind of first coined by Euclid in the maths here and Western math here, but this is the transitive property, my friends, the Transylvania property, transitive property of congruence. And you don't need to put that up congruence thing in, but I'm just putting it there. And there we have it. We got it proven. I'm going to cut the video right now. Feel free to ask me any questions about this. I will put this the video up and as well put up the example problems here too, so you see it in your assignment today. Good luck today, guys. Email me if you have any more questions, but then again, we'll review this on the Jamboard tomorrow. Have a good day, guys. Bye.